What is a capacitor? Take two electrical conductors and separate them with an insulator and you make a capacitor. Something that you can use to store electrical energy. Adding electrical energy to a capacitor is called charging and releasing the energy is called discharging. You might be wondering, if a capacitor is used to store electrical charge, how is it different from a battery? Capacitor stores much smaller amount of electrical energy compared to the same size of a battery, which is 10,000 times smaller than that of the energy that can be stored in a battery of exactly the same size. So in the given example, we try to compare a capacitor and a battery of exactly the same size, and at the end, we found out that the energy or the electrical charge stored in the capacitor was 10,000 times less to the energy stored inside the battery of exactly the same size. The second difference between a capacitor and a battery is that a capacitor releases energy very rapidly and often in seconds or less. However, battery releases energy very slowly through a circuit, and a good example would be a battery inside a quartz watch. It would take years to discharge completely. A good example of a capacitor would be a flash photograph. For example, you need your camera to produce a huge burst of light in a fraction of a second. A capacitor attached to the flash gun charges up for a few seconds using energy from your camera's batteries. It takes time to charge a capacitor, and that's why you typically have to wait a little while. Once the capacitor is fully charged, it can release all that energy in an instant through the xenon flash bulb. What is capacitance? The amount of electrical energy a capacitor can store depends on its capacitance. The capacitance of a capacitor is a bit like the size of a bucket. The bigger the bucket, the more water it can store. The bigger the capacitance, the more electricity a capacitor can store. How do we measure capacitance? Now, capacitance is directly proportional to the absolute permittivity of the dielectric and the area of the plates. And it is inversely proportional to the distance between the plates. And it is given by the unit farads. Now, 1 farad is a huge amount of capacitance. So in practice, most of the capacitors we come across are just fractions of a farad, typically microfarads, nanofarads, and picofarads. There are 3 different ways by which we can increase the capacitance. First is by increasing the size of the plates. Second is to move the plates closer to each other. And the third way is to make sure the dielectric has a good insulator as possible. Initially, we have equal amount of positive and negative charge electrons. If we try connecting the battery, the current will try flowing. That is, electrons from the plate connected to the positive side of the battery will start moving to the negative tip of the battery. However, because of the dielectric between the plates, the electrons won't be able to pass through the capacitor, so they'll start accumulating on the plate. After a certain number of electrons are accumulated on the plate, the battery will have insufficient energy to push any electrons because of the repulsion of the electrons already there. This point of time, the capacitor is fully charged. The first plate generates negative charge and the second plate has generated positive charge, creating an electric field. Once fully charged, we can remove the battery and it will hold the electric charge for a long period of time.